we go. We are going to try something today. We are using our new our sketch pad. We are at home and we are going to try to record this while being at home. So let's look. We got problem number 9. This is sorry for the introduction. That was pretty lame. We are going to, this is Marymount Algebra 1 placement. This is number 3 and part 3, problems 109 to 190. And we have the square root of 8 here, and we need to understand, now that's interesting. So that didn't work out so well already. Because I can't see my pen. I don't have my pen and eraser like I do here. So I guess we will. Maybe that's where the pens are. There are the pens. Is that where the pens are? Don't know. We'll try this. Yeah? Okay. Well, see, now I need the eraser. All right. That's not going to work. Sorry. What? Oh, that was a eraser. That was a magic pen. I'm sure I can fix it, but we're going to go. So the square root of 8 can be broken into the square root of 4 and the square root of 2. Why did I pick 4 and 2? Because rad 4 is a perfect square. So that becomes 2 rad 2. That's how we're simplifying these problems. These radicals, they're not perfect squares. So what we need to do is we need to break it down in order to simplify. Rad 27 can be broken into rad 9, rad 3. Rad 9 is a perfect square, so it becomes 3 rad 3. Don't assume that all of them are going to end up being similar to that component, but so we have 3 times, and now 486. Gosh, I mean, what's going to go into 486? I don't know. I'm looking for perfect square factors. So 1, 4, 9, 16, 25, 36, what's that, 49, 64, 81. So I'm going through, these are the list of perfect squares. And so 486, I mean, I don't think 46 is a perfect square. Maybe it is. We can do 486 square root. Nope. So not a perfect square, and hence why we know it's going to be simplified. So we got to find a factor. What goes into 486? Well, 4 goes into it, right? Oh, I don't want that. Oh, that's interesting. Well, maybe because I keep touching. There we go. So we know that we can break it into 4, and that goes 1. No, 4 doesn't go into 486. 486, okay. 36? So let's bring this back. 486 divided by 4 doesn't go in. That's not, so it's not 4, it's not the factor. 12, no, 486. Well, it can't be 36 because 4 goes into 49. Nope, 486. Oh, yeah. Can we do 30? No, 486 divided by 36. Close. 13. Oh, we need whole numbers. All right. Well, this is good for you. This is how we could also do it. It's clicking. I don't know if I like this pen so much. 486, we can do prime factorization. So 2 goes into 2, 4, 3, 243. 243 seems like a perfect square. Yeah, I bet you that is. 243. 2, 4, 3, square root. Nope. Okay, so 3 goes into 243 3 times, and that goes 81. There it is. So 81 times 6. So 3 rad 81, rad 6, 3, 9, rad 6. So we get 27 rad 6. Sorry about that. So this is good. Let's bring that down. That's our technique. And this is important. I mean, there's value of doing that. And notice we multiply. Oh, sorry, we're not done. We also have our variables. V to the third. So that gets broken into V squared rad V. And that V comes out. And we get rad V. So times V rad V. So 27 is on the outside, the V is on the outside, and 6V would be on the inside. So let's do number 121 or 112. We have rad 5 times 256. 256 is 16. 256 square root 16, yeah. So if we separate those, you get negative 5 times 16 times rad x. Rad x can't be simplified. So negative 5 times 16 is 30, 80. So negative 80 rad x would be my answer. I guess I should have the answer key here just to make sure that I'm giving you correct answers. Negative 80x, yep, good. Okay, let's move on to the next page. Now we're adding. So when we add radicals, radicals are very similar to variables. So when we have like rads, we're going to combine their coefficients. So those coefficients, negative 5 and positive 5, so they're going to cancel and you're going to just be left with 0. You would not be left with rad 2 because that would mean 1. So 113 is 0. We have like radicals, so we're going to combine their coefficients. 5 and negative 2 makes 3 rad 5. Well, we want to make sure that these radicals are simplified before we combine them. So negative 2 rad 3, negative 2 rad 12, we're going to break into rad 4, rad 3. And minus rad 54 is rad 9, rad 6. So we're looking for those perfect squares again. So negative 2 rad 3 minus 2 times 2 rad 3, because the rad 4 becomes rad 2, minus 3 rad 6, because the rad 9 becomes 3. It comes out of the house. So negative 2 rad 3 minus 4 rad 3 minus 3 rad 6. These are like terms, so we are going to combine their coefficients. Negative 6 rad 3 minus 3 rad 6. Those are unlike, so we cannot combine those. We're going to leave that as our answer. I don't think that there's an order for that. Negative 3 will make that rad 4 rad 3 again. Minus 3 rad 9 rad 5. So we'll simplify. Oh, and then minus 2 rad 5. So this is negative 3 times 2 times rad 3, which is negative 6 rad 3. This is negative 3 times rad 5, which is negative 9 rad 5. Minus 2 rad 5, minus 2 rad 5. And these are like terms. So negative 6 rad 3 minus 11 rad 5 would be my answer. Let's check. Negative 6 rad 3. Yep, good. Let's keep going. 112. Well, let's look. 4. 4 will go into that. 4 goes into 112. 112 divided by 4 gives us 28. Rad 28. So this becomes 4 times 2, Rad 28 is 4 rad 7. So 4 times 2 times 2 times rad 7 is 16 rad 7. Let's minus 2 and 128. 4 goes into that. 32, which has a 16. So this is minus 2 rad 2. No, 2 times 2 because it came out. This is rad 16 times rad 2. So that is negative 4 times 4 rad 2, which is negative 16 rad 2. And we had that rad minus 2. That's rad 16 rad 2 minus 2 times 4 rad 2, which is minus 8 rad 2 minus 8 rad 2. These are like terms. 16 rad 7 minus 24 rad 2 for 117. Uh-oh. Made a mistake. Oh, no. Oh, I forgot this one, didn't I? So, yeah, sorry, I skipped that. So let's combine that. Let's see what that is. I can't see. That's a negative 2. So negative 2 rad 7 is going to give us a total of 14 rad 7 minus 24 rad 2. That is the correct answer. 280. Well, we can do rad 4 rad 20, which is rad 4 rad 5. So that's 2 times 2 times 2 times rad 5, which is 8 rad 5. 2 rad 8. 2 rad 4 rad 2, which 4 rad 2 plus 4 rad 2. Rad 20. Oh, I have no idea what I just did. I think I just changed the page by accident. Sorry. Negative rad 20 is negative 2 rad 5. I know that. You should know that. Negative 4 rad 5. And then we have plus 4 rad 5. Doesn't have to be simplified. So we have coefficients, coefficient, which is 610 rad 5 plus 4 rad 2. That should be the answer to number 18, 10 rad 5 plus 4 rad 2. Good. This is one of the silliest. Look at these two questions. Tell me you don't look over your placement material without telling me you didn't check your placement material. I mean, this is really lazy. It's 2 rad 2. It's the same answer because it's the same question. Okay. Here we're going to distribute. We can't simplify anything. We can't combine them. They're not like terms. And we can't simplify rad 10. So we're going to multiply negative 2 rad 15 times 5 minus 2 rad 15 times rad 10. So outside with outside makes negative 10 rad 15. Outside. But notice we have rad 15, that's rad 3, rad 5, and we're multiplying it by rad 10, which is rad 2, rad 5. So these two like radicals multiplying will come out with this negative 2. So it's negative 2 times 5. And then these inside are going to stay inside rad 6. So it's negative 10 rad 15 minus 10 rad 6. Would be my final answer for 121. And same thing here. We're going to have 5 rad 15 times rad 10 plus 5 rad 15 times rad 3. Rad 15 is rad 5 rad 3. 10 is rad 5 rad 2. So we have 5 times 5. That second 5 came out because we multiplied rad 5 and rad 5. So that gives us rad 3 and rad 2 gives us rad 6. 25 rad 6. And now we have 5. So that's plus 5. Rad 15 is rad 5 rad 3 times the rad 3. So that's going to give us 5 times 3 rad 5, which is 15 rad 5. Here's the unfortunate thing about this workspace, this work tablet, is that my handwriting is not as crisp. Oh, I forgot about this. Crisp. Let's see if we can make it crisp now. I forgot to do this earlier. Sorry. 25 rad 6 plus 15 rad 5. Yeah, a little bit better. So let's do this. Want to do auto height? Does that change anything? No. Well, no, I don't think it does. All right. So this is foiling. We're going to multiply firsts. We're just double distributing, double distributing, double distributing. My lines are a little bit wigglier. So 6 rad 7x times 6 rad 7 plus 6 rad 7x times 3 rad 6x minus 2 rad 6 times 6 rad 7 minus 2 rad 6 times 3 rad 6x. So outsides is 36. This is not better. That was definitely not better. 6 times 6 is 36. We're going to break that rad 7 rad x. Kind of do like it a little bit better. Well, let's try this. Rad 7 times rad 7 is going to give us times 7 and then the rad x. So that's 42, 42, that's 252 rad x. Let's multiply these. You have outside times outside. That is 18. Now rad 7, rad 7x is rad 7 rad x, rad 6 rad x, and these rad x's are going to come out. And then this is left inside, so that's rad 42. That can't be simplified. There's no common factor there. So we have 18x rad 42 minus 12 rad 42, because those don't have any common. And then we have negative 2 times 3 is negative 6. Rad 6 times rad 6 times rad x. So that's going to be minus 6 times 6 rad x, negative 36 rad x. Do we have any like terms? We have these like terms, so we're going to combine their coefficients. That's 2, 1, 6 rad x plus 18x rad 42 minus 12 rad 42. You say, Mr. Mack, they have the same radicals, but look at their coefficients. We can't combine those coefficients because they're unlike terms. So yes, the radicals are like terms, but their coefficients can't be simplified. So number 23 is going to be that long-winded thing. So sorry, we are going to distribute, double distribute, double distribute, double distribute. So let's do that. Let's just do it. Negative 5 times 5 is negative 25. Rad 5n times rad 5n is going to be just 5n. That comes out. Now we'll do the next, that's negative 10. And rad 5 times rad 7 is going to just give us rad 35n. Nothing comes out. You have this second distribution, that's 25 rad 35n. And then that's going to give us negative 10 times 7. So we can multiply those. That's negative 125. Stop touching the button. These are like terms, and the coefficients can be combined to make 15 rad 35n. And this is negative 70. These are those are not constants. So, oops, sorry, that's minus 70. So this is our answer. No like terms, and I think that's kind of the order that it should be in. Negative 125n minus 70. Did I make a mistake? It says positive 35. Where did that negative, oh, negative 5. Sorry, negative times a negative is a positive. So that is 35. Maybe you saw that. You saw that mistake from Mr. Mac. Sorry about that. Good. Okay. We're golden. Now we have radicals in fractions. So we have 2 rad 3. Let's simplify that denominator to rad 9 rad 3, which becomes 2 rad 3 over 3 rad 3. We're going to cancel these. Cancel those out. And that leaves us with 2/3. Boom. Here we can simplify that rad 16, That rad 16 is a 4. So, and that rad 9 is a 3. These can cancel. So we're left with 2/3, I think again. Kind of liking this so I can move through. All right, this is the hardest part. So there's nothing we can simplify here. And we have to rationalize. We talked about this. I don't know if we talked about it in this video or a prior video, but to rationalize radicals, so you're not allowed to have a radical in the denominator. So what's going to get rid of this radical in the denominator is another rad 3, an identical rad 3. Now, since we don't want to change it and we want to make it equivalent, we have to multiply it by a value of 1. So that is going to become 2 rad 3 over 3. The reason why we multiplied it by itself is so it comes out. And then this would be this original fraction being rationalized. Now that's good when there's a single radical. Here we have a binomial. So we can't just multiply by itself. This won't get rid of it because that inside and outside will create a radical. So we have to multiply by its conjugate. Why conjugate? Because it will get rid of the outside and inside. So, and what we multiply by the numerator, we have to multiply, or by the denominator, we have to multiply by the numerator. So to keep it as a value of 1, we're going to distribute this. So we get 16 minus 8 rad 2, outside with outside. Here, when we multiply conjugates, you get 16. Our outside and our inside are going to cancel. So the only other one is our lasts. That will give us negative 4 times 2. So we get, let's grab this. Let's grab all that. Let's make that smaller group. Boom. Make it smaller. Move you down a little bit so we can do some more work. 16 minus 8 rad 2. Oh, that's a 2. Rad 2. And push the button. Thanks for being patient. Thank you for being patient. 16 minus 8 rad 2 over 16 minus 4 times 2 is 8. So we get 16 minus 8 rad 2 over 8. And we also talked about this, was we see these three coefficients outside. We have 16, negative 8, and 8, and they have a common factor. So we can reduce that. So 8 goes into that, so that's 2 minus rad 2 over 1, or 2 minus rad 2 for 127. That's a good one. Oh, I forgot to take off the auto hide. So what is the conjugate, or what is the conjugate to that to get rid of it is 3 minus rad 3. Minus rad 3. Distribute that numerator, 6 minus 2 rad 3 over 9 minus 3, which is 6 minus 2 rad 3 over 6. Did you see? That gave me my 9. I didn't have to do the outside and inside because I knew they'd cancel. And rad 3 times rad 3 is 3, but I have a negative and a positive, so that's why that's that. It has a common factor of 2, so I can reduce those. So I'm going to reduce it by 2, and that gives me 3 rad 3 over 3. 3 minus rad 3 over 3. That is a fun one. Yeah, that's the answer for number 128. Let's move this down. We got lots of work. What are we, 45 minutes into this one? Oh, look at that. 7 times 128, rad 128. We're going to separate the m to the third. We're going to separate the rad n, and we're going to separate the p to the fourth. So 128, 64, yeah. So we can make that rad 64, rad 2. Here we're going to make rad m squared, rad m. Rad n doesn't get rid of anything. And this is going to be rad p squared, rad p squared. So 7 times 8, rad 2 stays in. Rad m squared is m on the outside with my leftover rad m. My rad n stayed in. My rad p squared, a p comes out and a p comes out. So we got all these outside things, which is 56 m p squared times 2 is inside, m is inside, n is. So 2mn would be our final answer. I like that. And, oh, it said use absolute values when necessary. So we wouldn't use absolute values for the fourth because anything that's any negative number is going to get squared. And this isn't coming out. So the only one that you would have is 56 absolute value of m p squared rad 2mn. If you want to do that, I don't know how many teachers expect that absolute value, but it would be your odd exponent. Your even exponents, your negatives would not be affected by it. Here we go again. So negative 576 rad m to the fifth, rad p to the third, rad q. Let's see, that's good. So 576, I don't know, well, 576. 576 square root 24. Sorry, I'll get better, I'm sorry. Negative 24. This is going to be rad m squared times m squared times m This is going to be p squared times rad p, and this is going to be rad q. So negative 24, that's going to be m times rad m times p times rad p times rad q. Now negative 24 m squared p, and then we have mpq. Now you're gonna ask me, Mr. Mack, why don't I do, oh, and absolute, oh yeah, sorry. So I like that answer. Now if you want the absolute value thing, you could have this around the p because that was an odd exponent. And then it's rad mpq. Why didn't I do a absolute value on this odd one? Because it was squared, and we know if it was negative, it would have gotten rid of it. So only if it comes out and it's odd is the other reason. Don't know. Find the slope. This is in y equals mx plus b, m representing the slope. So the slope of this line is 5/4. The slope is going to be the coefficient of x, so the slope is negative 5/2. Find the slope. We're going to find 2 points where they intersect on a grid line. Slope is rise over run, meaning our up, down over our right, left. So how much do we go up? We go up 1, and then we go right 3. So it has a slope of 1/3. We got to find 2 points on the grid, on a grid line, and it's kind of hard because my eyeballs and this thing is, I can't tell what's on a grid, but we can give it a good shot. That's down, so I'm going to start with this point and move to this point. So I'm going down 1, 2, 3, 4, 5, 6, 7, 8, down 8, and then I'm going right 2. So down is negative 8, right is positive, so I have a slope of negative 4. Find the slope of the line parallel to each given line. Okay, so first we have to put it in slope-intercept form. So I got to isolate for y. Slope-intercept, so we're going to divide by 4. We get y equals x over 4. We need to understand that that is equal to 1/4 x, and parallel have the same slope. So my slope is 1/4. We're going to solve for y. I'm going to make it a little bit easier on myself. I'm going to add y, and I get 1 equals y plus 4x, and then I'm going to subtract the 4x. So I get negative 4x plus 1 equals y. My slope is going to be the coefficient of x when isolated for y, so negative 4. Oh, I didn't mean to do that. Can I undo that? I thought I could slide the slides. All right, now we're going to find the slope of the line through each pair of points. We know that slope equals rise over run, or the difference of y's over the difference of x's. And we have a formula for that, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So all of that, oh, that's nice. That can go down there. So we're going to use this, and we have 2 points. X sub 1 and x sub 2 means the x value in the first point, the x value in the second point. Y sub 1 and y sub 2 are the y values in the first point. So we have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. My y sub 2 value is negative 4 minus my y sub 1, which is 2, x sub 2, which is negative 3, minus my x sub 1. So that's negative 6 over negative 20, which simplifies to positive 3 over 10. Two negatives cancel. Number 137 is 3 over 10. X sub 1, y sub 1, x sub 2, y sub 2. Y sub 2, 20 minus y sub 1, which is negative 18. X sub 2, negative 12 minus my x sub 1, which is 4. Two negatives make 38. And negative 12 and negative 4 is negative 16, which reduces to 19 over negative 8. 19 over negative 8 would be my slope. Sketch the graph. So this is in slope-intercept form. So my slope is equal to 1, and my y-intercept is equal to negative 3. We always plot a point first, negative 3, and then we use the slope, which is 1. Let's make it into a fraction so we know we're rising 1, running 1, rising 1, running 1, and then we can connect the lines. Make sure you write arrows. Some of them want you to put coordinates. We're not going to do that because it doesn't say, it just says sketch, but sometimes you put the coordinates next to the point, not out here into this space, right next to the point so we know what we're talking about. This has a y-intercept of negative 2, so we make that dot at negative 2 at a slope of 4, up 1, 2, 3, 4, right 1, up 1, 2, 3, 4, right 1, and we're going to connect the dots. Let's make arrows, and that is our graph. So this is not in any form. We're going to convert it to slope-intercept form because converting to slope-intercept is putting y by itself. So we're going to subtract the 6x. We get y equals negative 6x plus 3. So my slope is negative 6. My y-intercept is 3. Let's go to the y-intercept. And then slope is negative 6, down 6, 1, 2, 3, 4, 5, 6, right 1. And that is going to be enough for me. Just moving them around a little bit, giving some, because the next point would have been off of the grid. So that's why I can only plot 2. This is not in any form. So I can either put it, let's put it in slope-intercept form. Let's solve for y. Well, what do you want to do? Let's minus 3y. So you get negative 3y equals negative 8x minus 15. We subtracted the 3y from both sides. Let's divide by negative 3. We're going to divide everything by negative 3. So we get y equals 8/3 positive, 2 negatives make a positive, plus 5. So, sorry. So my y-intercept is 5. My slope is 8/3, so up 8, right 3. Well, I don't have space to go up there. So I can do the opposite of that. I can do negative 8 over negative 3, which I initially had. I would never leave it like negative and negative, but I can think of it. So that means down 8, 1, 2, 3, 4, 5, 6, 7, 8, and then left 3, 1, 2, 3. That's a nice creative way of being able to sketch a slope that went off of the grid. This is in standard form. We can find the x, so standard form is ax plus by equals c. And this is really good for x-intercepts and y-intercept. When you do the x-intercept, the y value is 0. When we do the x-intercept, the x is 0. So taking 2x minus 3y equals negative 6 and plugging in, if we're going to find the x-intercept, we're going to plug in 0 for y. So you get 2x minus 3 times 0 equals negative 6, or 2x equals negative 6. I call it the cover-up method because I just cover up one side and solve, cover up the other side and solve. But we'll show all the work for right now. Negative 3, so that's an x-intercept on the x-axis at negative 3. If I want to find the y-intercept, I'm going to plug 0 in for x. So same equation, but this time I'm plugging in 0 for x, which again just leaves me with negative 3y equals negative 6, divided by negative 3. Y equals positive 2. That's my y-intercept. A lot of students think that this is a point that they make the point to negative 3. That doesn't make sense anyway, because I told you these are intercepts. So that would be a point that is not an intercept. So that wouldn't make any sense at all. We got a whole bunch more work to do. This goes up to 190. I may have to stop this video, end this work at this point and save it and post it. But we'll keep going. We'll see. Sketch a graph of the line. So this is in slope-intercept form. But that's not good. So if we cover up, notice we would get negative 4/3. Who wants to graph negative 4/3 on the x-axis? Not me. So we will take this and move it into slope-intercept form. Minus 3x minus 3x. 4y equals negative 3x minus 4. Divide by 4, divide by 4, divide by 4. We get y equals negative 3/4 x minus 1. So negative 1 on the y-intercept, down 3, 1, 2, 3. Right 4, 1, 2, 3, 4. Or up 3, 1, 2, 3. Left 1, 2, 3, 4. Now you'll see, well, I didn't draw that. I did this. No, I want a line. You'll see when we connect these dots that that intercept, that x-intercept would have been a little funky. It wouldn't have been on a grid line. You see, it would have been on a third. So that's why I went with slope-intercept form here. Now we have to write the slope-intercept. So I have to find the slope and the y-intercept. This is my y-intercept. I'm going to find another point, and I'm going to see what is my slope. So my y-intercept is very easy to see. That is 3. And then my slope, how much do I rise and run to get to those points? I'm going to go down 1, 2, 3. And then I'm going to go right 3. Down is negative 3. Right is positive 3. So I get a slope of negative 1. Now we use the template y equals mx plus b. Y equals, we're going to fill in for slope, which is negative 1, and we're going to fill in for our y-intercept is 3. And a good mathematician would write it without a 1. We would write y equals negative x plus 3. Yeah, I don't like this because it's so sloppy. We'll see how much. Ooh, my hand's cramping too because it's a little teeny pen. We'll see if we can find a more accurate pen. Right, in slope-intercept form of the equation, we're going to minus 3x. We get 7y equals negative 3x minus 28. Divide by 7, divide by 7, divide by 7. We want to isolate y. That's negative 3/7 x minus 4. And that would be in slope-intercept form. That's good. Let's go to the next one. This is point slope form. I don't know if you knew that. So we can do a couple things. We'll do the most logical. A lot of people will distribute and then isolate and get y by itself. So we get y plus 2 equals negative 3/2 x minus 3. Negative 3/2 times 2. 2 in the numerator cancels with 2 in the denominator, leaves us with the negative 3. And then minus 2. And we have isolated our variable to put it in slope-intercept form. Yeah, it's a nice one. Right in slope-intercept form, I'm going to add y plus 1/5 x equals -4, and then I'm going to subtract 1/5 x minus 1/5 x. We get y equals -1/5 x minus 4 for number 148. Write the slope-intercept form when you're given, so y equals mx plus b. Notice that my slope is going to, my slope is going to go in for m, my y-intercept is going to go in for b, and I just substitute those values. Y equals -1/3 x plus 5. That's nice and easy. These are right slope-intercept form. This is a point. This is slope. There's two ways. There's multiple ways we can do it. We could put it in point-slope form. Point-slope form. Not a lot of students know what point-slope form looks like. Y minus y sub 1 equals m times quantity x minus x sub 1. Y minus the y value, which is 1, equals the slope, which is 4/3 times x minus the x value, which is 3. We would distribute 4/3 x minus 4. Again, that 3 in the numerator, 3 in the denominator, cancel 4 in the negative. And then we would add 1. Y equals 4/3 x minus 3. That's going to be the easiest way to do it. To me, is there a negative somewhere here? 150. Oh, no, there's no. Yeah, good. The other way you could have done it is y equals mx plus b, where this is your x and this is your y. So you plug in the y, you plug in the slope, you plug in the x, and then you solve for b. So this is 1 equals 4 plus b minus 4. Minus 4 gives me a -3 for my b. And then we can rewrite it as y equals the slope minus the b. Both, this is definitely less work, but this might make more sense. Either way, so slope-intercept. So if I'm going to do slope-intercept, I need to figure out what the slope is. So I'm given 2 points, x sub 1, y sub 1, x sub 2, y sub 2. So we do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That gives me 1 over 4. So I can fine-tune this. I know my slope is 1/4. Now I got to find the b value. So I can either, that's the slope, I can do that formula, I can plug in, I have a point, x and y represent a point, so I can take this equation and take a point. So I'll take the first point, -2 equals 1/4 times the x value, which is -3, plus b, because that's what I'm looking for. -2 equals -3/4 plus b. We're going to add 3/4, add 3/4. Hopefully you're good with your fractions. That's -8/4, and -8 and +3 makes -5/4 equals my b. So I can finish that. That is 1/4 x minus 5/4 would be an equation in slope-intercept form. Right, the slope-intercept form through parallel. So we know that lines that are parallel have the same slope. So we can do, I'm going to use point slope because I have my slope and I have a point. So y minus y sub 1 is 5 equals the slope, -7/4, times x minus my x sub 1, My x value is negative 4. So that is y minus 5 equals negative 7/4 times x plus 4. Let's distribute. Negative 5 equals negative 7/4 x. These 4's cancel. You're left with negative 7. Let's add 5. Y equals negative 7/4 x minus 2 would be the equation in slope-intercept form.